Okay, so we are back, and Ace, this will be a good one of how to deal with when you have X or variables in the denominator, or you have something creepy, because the rule that John explained to you about finding the derivative works for any kind of power. It doesn't have to be a polynomial. It can be a fraction, it can be a negative, it can be any of that. So the first thing I would do to find the derivative is rewrite this as, what would I put? 5x minus 32x to the 1/2. Hold on, I'm just rewriting it. Minus.
I put 1 over 16 square root x.
Not 1 over 16. 1/2 times 32 is just 16.
16.
And then x
To the 1/2.
will be negative 1/2. And this comes to something that you remember, you were just jotting a problem down real quick. That is the same as 16 over the square root of x. The 16 is not being raised to a negative exponent, just the x. Yeah. That's a common mistake. I totally expect that, but don't do it from now on. But Miss White, why did I even bother simplifying it? Well, I can't plug in a number without it being in this form. I can't take the derivative without rewriting it in this form. And then I can't plug in a number in my head without writing it in this form. I'm sure you could have easily found a smarter calculus teacher, but I'm not it. Anyway.
Not a better one, though.
Do what?
There's not a better one.
Yeah. Boy, you're just laying it on thick today, aren't you? So if we plug in 4, we'll have 16 over the square root of 4 to 5 minus 8 is negative 3. Shoot, I can barely add and subtract, let alone take the derivative if it's not in the right form. Anyway.
I can't even read. This is ridiculous.
You can't what?
I can't even read.
Read? Okay. And is this just, hey, some of the questions on Delta Math are just going to ask you for the slope. So the slope at x equals 4 is negative 3. Okay, but that is just if it asks you for the slope. This one is asking for an equation, the full Monty, if you will. And so we know our slope is negative 3, and we know our point is for what?
It's going to be... it's going to
Ooh, big old number.
Negative 44.
Negative 44? Is that right? Yeah. And we plug that into the original, not the derivative. Okay? Again, this is all about the slope, and the point is on the original graph. So y minus negative 44 equals negative 3 x minus 4. And by the way, I'm pretty sure Delta Math would accept this even with the minus in it. So you literally can just leave it like that, or do it your way, and let's make sure you get the right y-intercept.
Y equals...
I'm really not trying to convert you. I'm just like, this is my first go-to when I write the equation of a line.
Y equals negative 3x minus 32.
32. Is that right?
Yeah.
Yeah. Okay.
It's going
Yep.
to be negative 44 plus 12.
So either one of those are completely fine. Again, just solving for B and then putting it in there is totally fine. I don't care either way. This is just my go-to. That's what Miss White's been doing since 7th grade. So, little known fact.
It's an interesting looking equation. the original is.
Yeah, this.
Yeah.
What it actually is good for is you can actually see the transformations. Some algebra teachers call this transformational form because you can actually see that it is aligned with this slope and it is moved to the right 4 and down 44. And it's, so it, yeah.
It's like vertex form.
Yeah, it is very much like vertex form.
Except there's no vertices.
Right. All you have to go with is the original line of like y equals x, you know. So, yeah. Anyway. Okay, find the points.
On a different equation.
This is a different equation, and it might actually even be a little bit misleading. Find the points on the graph at which the slope of the tangent line is equal to 4.
But this is a quadratic. There's only going to be one point.
Very good. If y'all didn't hear that, I actually know that there's not going to be more than one. The derivative of a quadratic will be linear, and so there's only going to be one place where the slope is going to be equal to 4. So we take, oh, by the way, y prime is also a decent notation for the derivative. Did I talk about that last time?
Yeah, f of x.
So f prime of x, y prime, or dy dx, which, by the way, who learned delta y over delta x for slope? Did your algebra teacher write it like that? That is literally why this is dy dx.
I don't like
It's
writing-
literally delta y over delta x.
I don't like writing dy over dx. Whenever I think of dx, I think of the infinitesimal.
Okay.
This is necessary. It's not necessary. It is the best thing to do when we will be doing related rates problems. We'll get to that. And you want to make sure and write it like that. But really flowing in between these different notations is just the best way to get familiar with all of them. So anyway, so y prime is going to be, what's it going to be? What's my derivative going to be?
Oh, so
2x
plus 3.
plus 3. And that's it.
And then you
So if I want to know where the slope, see this actually is the slope at 4, not at 4, I'm sorry, I said that wrong. Because there are strange things happening among the boys in my room. I don't know why they're giggling at each other. Anyway,
Sorry, I'm bad sneezing. Can't sneeze? I can't sneeze.
oh, you're having trouble sneezing.
No, I just can't do it. It's impossible. I am a bad sneezer.
Wow. Okay, so we want to know where the slope is equal to 4. So literally, I want to know where this equals 4. I'm not plugging in 4. I want it to equal 4. So 2x equals 1. So x equals 1/2. Ew. Oh, man. If it wants the point, then it wants a coordinate, x and y coordinate. So, ew, plug in 1/2. What's that going to be? One.
Negative 21/4.
1/4 plus 3 halves minus
Forgot the negative.
7.
So 7/4 minus 7.
Wait, what? Oh, yeah, 6 7/4
Minus 7.
minus
It's negative 21.
7 negative 21/4. Very good. I'm hoping that
That was a good reference.
this is. I think the ones on Delta Math are like you won't have to plug in a fraction or anything. I don't think so. Anyway, I might be able. You might be able to correct me on that.
Plug in all the values.
But-
Sine of x equals 1.
This
7 over 4 minus 7.
this lesson on writing the tangent lines is really Seemed rather easy today, right?
That's supplemental.
It's something that we come back to quite often. Okay, and some people are like, well, I don't know how to write. Yes, we wrote these equations long ago. My second year students will be reviewing, and they'll see one like this and go, "Durr," you know.
Is there a way to get a linear tangent line? But so say you have a cubic, can you possibly get a quadratic?
So the derivative of a cubic will be quadratic. I'm sorry, there's a half-eaten apple rolling beneath you, and I cannot even take it. Gross.
It skims the wall as it like. I mean, like say you have.
Good question, guys. Y'all listen.
Say you have
A cubic,
a cubic.
like this.
Yes, or
Okay.
like that, where there's then possibly be a quadratic where it only intersects once, or only touches it at one point.
So when we look for the tangent line to the graph, it is just touching that curve at just one spot. That is the definition of a tangent line.
Yes, but it is possible for a circle to be tangent to a circle.
Yeah, but that's not.
Oh, correct,
Yeah.
correct. But we're that's not
So
the scope of calculus. Honestly, the very first main point of calculus
yeah.
is just the actually, and we when I was speaking about this derivative, that notation for the derivative, actually one of the applications is taking, okay, let's say we have a circle and its equation. Sorry, my thumb kind of let out on me. I'm better than that. But anyway, yes, there are actually two spots where the slope of the tangent line will be a certain value.
There's that on, any sine wave too.
Yes.
Any wave or
Sure. Yeah. Yeah. And this is not a function, but you can still find its derivative. But when you're doing that, you're working with two variables, and that is why this notation is important. And I'll get to that for sure.
So
Anyway.
would be finding a quadratic tangent to a cubic fall under differential equations.
That's usually not the goal. But yes, you could find it. And you could find it by doing differential equations. I just never have. I've never had any reason to do that.
Yeah, I was
But you
asking
can.
more if it was theoretically
Yeah.
possible
Mhm.
than whether it was actually useful.
Yeah. Okay, thanks for joining me.